Yeah, hi, afternoon, everybody, and good morning to those of you in America, and welcome to the 12th Beyond Search Special Interest Group webinar. My name's Graham Charlesworth. I work for Pureinsights, and just for those of you who are here for the first time, and I know some of you are, I just wanted to say a few words about the purpose of the group. We formed it in 2020 when we created Pureinsights, and it's really a kind of a community for people like us who share an interest in search and AI. And we come together every 6 months or so to hear case studies, watch demonstrations, talk about advances in technology and so on. Occasionally we get one of the product vendor along. And we've done, this is the 12th one, we've done 11 of them so far, and along the way we've had presentations from a lot of the members who are on the call today. European Union Publishing Office, we've had Merck, pharmaceutical company, we had who else have we had? Elsevier, the publishing company, the STM publisher. We've had BASF, we've had Mintel, the market research company, and last time round, back in March, we had Kerry Group, who were one of the big food and drink product and ingredient companies. So a real kind of mix. What we wanted to do today, and this is kind of by popular demand actually, so a number of you have kind of reached out to us to ask if we could cover this topic, and we're calling it Making AI Search Work. Okay, really simple heading. And the reason I think why it's so popular and why it's been requested is that what we're observing and what we have been noticing for quite some time now is that, you know, whilst it's quite easy to create a demonstration or even a POC of a kind of question answering system or RAG-based system, actually getting it into production can be incredibly challenging. And, you know, quite often you find that although it sort of works from a functional perspective, the business will push back and will say, look, it's not accurate enough, or it's serving up some really some questions and answers rather that we're not happy with, or it could be that the performance isn't right, the latency is just too slow, and in some situations that we've been involved in, whilst it's been fine from a kind of functional and performance perspective, it's just been too expensive. And the cost of running the service with all the infrastructure cost meant that it's just not viable. So, so anyway, these are the sorts of challenges that people are facing and we're facing on engagements today. And we just thought it would be useful if we shared some thoughts and we just talk you through the processes and the patterns and so on that we tend to follow in situations like this, and just share with you our experience and our kind of tips and tricks, if you like. So anyway, I'm going to hand over to Matt Willsmore in a minute, who is one of our lead architects who will be talking you through this. And I know a lot of you have met and worked with Matt already, but just a few housekeeping items before we do that. If you could post any questions to the chat window as we go. We will have a Q&A session, as we always do at the end, which will be sort of 10 minutes. But if anyone's got any questions along the way, if you can just post them. And then Phil Lewis, our CTO, is also on and will do his best to answer as we go. And then we can have a general session at the end as well. So yeah, if you could do that. We will be recording the session, so hopefully you're all okay with that. And there we go. So with that, let me hand over to Matt, and then I'll join you again in 50 minutes or so for the Q&A session. Okay, over to you, Matt.
Thanks, Graham. Nice to meet you, everybody, and thank you for turning out on this ridiculously hot day. My name is Matt Willsmore. I work as an architect at Pureinsights. I've been working in the search industry for about 20 years, so more latterly working with AI. And, you know, at Pureinsights, I suspect the majority of the people on the call are involved with one or two search projects at most, maybe. We're in an interesting position of being across many. I mean, I'm across dozens for this too. And so we start to see certain patterns and, common pitfalls that people run into as they try and go from a fairly simple RAG or AI search implementation into something that they can really roll out. And a lot has happened in the last couple of years. You don't realize. So around about 2/3 of Fortune 500 companies have now deployed at least one RAG to production, as compared to only about a third in 2024. So people are applying these techniques and getting these things rolled out. But that doesn't mean that there aren't fixes that need to be made along the way and different approaches that need to be tried. So we thought it would be useful for us to just run through those. It's going to be relatively high level. I'm not going to jump right into the technical detail because we've got a mixture of people on the call. But there is a technical element to it. And I've got quite a lot to cover, so I'm going to go relatively fast. So if we could save questions to the end, that would be great. Or as Graham said, pop them into the chat window. So it's a fairly structured presentation. I've got 4 different areas that I'm going to cover. Data indexing and ingestion, information retrieval, answer generation, and performance and cost at scale. Each of them have got different sort of challenges, and they all need to be working right, really, to make it to production. The way I've structured this is I've got a slide with 3 challenges and then 3 slides with some solutions on it. So I'm not trying to cover everything you might encounter, and I'm certainly not expecting every RAG or AI search implementation to use all of these techniques. What we're hoping really is that some of you will see something here and think, oh, that's a good idea, or I'd like to know more, or perhaps I'll try that. So without further ado, I'll jump straight into some of the things we see in data ingestion. This one, some of the points will be very familiar to most of you, so I'm going to go relatively quickly through this one. The others are a bit more sophisticated, I guess, so I shall go relatively fast through here. So section 1, data indexing and ingestion. Obviously, getting the data in to your system in the correct format is going to have a huge impact on how well any retrieval system can get hold of it and extract it back out again. So not to be neglected. Most RAG systems or AI search systems, you tend to have to take a larger document and deconstruct it into what we call chunks. And the naive approach that most people take is to take a fixed size, so let's say 1,000 words or tokens, and that forms your trunk, and you may have between 1 and n chunks that constitute your document. The trouble with this is that you lose a load of structure in your document from that. By taking a fixed size, you can end up with your headings and your body separated from each other. You might slice through the middle of a set of table rows. You might lose captions, and more importantly, you're losing the bigger picture of what an article might be about. So you can end up with orphan statements that don't really make sense very much. And this is the approach that almost everyone starts off with. We certainly did, and most of our customers did. You just kind of, right, I'll see if that works. And it will get you a long way. And in some cases, it's fine. But often you start, as you try to increase quality, you start to need to use other techniques as well. And one other expedient measure that people take is to just chuck away the tables and the images and things and not really use those. Unfortunately, in certain domains, they contain a lot of important information. So whereas you can probably get away with that with the search implementation, with a question answering implementation, you kind of need to have all the information there, because you're not just pointing somebody off to a document. You want to use all of the content. And what that leads to is poor retrieval signal. You've got sparse chunks that don't have necessarily all the information they need in them. And you can end up with perhaps fairly good recall, but low passage precision. So your chunk is coming back, but it's nowhere near the top. So those are obvious and very commonly seen problems we see in ingestion. And so some of the solutions we see is to leverage the structure in the document. It seems fairly obvious, but people are only sort of starting to, or a lot of cases, people are only starting to do this. So you use HTML parsers, you can use the outline in the documents, maybe you use your XML versions of the documents instead, which have a bit more structure. And then you can formulate natural and semantically meaningful chunks. They might all be different sizes, but you've got all the content you need in one place. Another technique we see is to try and link the child chunks to their parent. So what you might do is have a pointer off to maybe another collection that contains more of the document or the sibling chunks, so that you can assemble a bigger context to feed to the language model. Or indeed, you could have a document summary which you pass in with a chunk that gives a bit more context. And then the third technique we see is semantic chunking. Now that's where you take some sentences or paragraphs and you do a sort of clustering algorithm on them. So you look at the similarity between the different elements of your content and you try and identify natural breakpoints semantically where perhaps the theme or the topic changes. There's various tools out there for doing that. Some of the big frameworks that people are using for AI implementations have several implementations of that. And we're now using that with our clients quite effectively. It's starting to get to the point where you really need to be looking at that so you don't run into problems later on down the line. And the tools are getting much more mature. Llama Index is one, or Llama Parse is one. There's another ingestion tool called Dockling, which has come from IBM, which is becoming very popular. Whereas in the search days, as I say, you might have been happy to throw away some content. These days, just having a kind of content standardizer that has neat blocks of content might not cut it, and so the tools have adapted to suit that. And then just a bit more on table extraction. This has been an area of focus with, so I should just backtrack a bit and say the learnings in this are from multiple engagements, many of them ones that I've been involved with, but not entirely. Some of them from Phil and others in the team, of things that we've done to try and prove out approaches with our customers. So there's a mixture, and sometimes these pieces will apply to more than one customer. This piece at the top, table extraction indexing, applies to a couple of pieces of work that I've been involved with. One of them, they already had the tables represented as JSON. Another one, we were converting tables in documents into JSON. And what you can do then is use aggregations or facets within a search engine to provide summary information, and then interrogate that in a clever way using an agent. So you get me the summary from this table in this document. Quite interesting stuff to get to calculate table stats from semi-structured content. We've also done some work with very image-heavy domains. In this case, an auction site where we develop very rich descriptions using an image model to basically generate a large description, which we can then interrogate. And then the last technique around enrichment is metadata enrichment. Phil calls it metadata stuffing. It's essentially getting the important metadata and making sure that's present in all of your chunks. It's kind of essential. Even if you do know more, just make sure the metadata is available, because provide that little bit of context. And then finally, there's a technique called HIDE, hypothetical document embeddings, which takes several different forms. The ones that I've encountered are to create essentially, if you've got a low quality chunks, or they perhaps don't have a lot of context because you've got a very long document with lots of clauses or something, to provide a generated enrichment that describes what this is about in a bit more detail. or as a summary, or you match against questions that you've generated. So you say, what can this chunk answer questions about? And you're searching a question against a question, which when the jury's out about whether that works better, but it's certainly an interesting technique that we've tried with some clients. And it can be that hide is useful for certain contexts. So where you want to describe a table so that you can understand what it's about. And what kind of questions you can or information you can get out of that table or other piece of content. And in some cases, we'll use entity extraction to pull out companies and names and products and so on in order to make sure that they're available as additional metadata. So essentially, what I'm talking about here is using an LLM to enrich your data as it comes into the system to make it more amenable to embedding-based search. So that's for ingestion. Section 2, information retrieval, things to get a bit more sophisticated here. We're finding that as people go from POC or pilot to production, they are finding that there's certain classes of queries that their approach doesn't work for. So not all queries are going to be semantic. Sometimes you need to work out that somebody's looking for a part number. In that case, it needs to be a very precise search. So you wouldn't want to use a vector model to do that search. In other cases, you might need to find the relationship between some entities that requires perhaps a graph lookup or even a relational DB lookup. So more and more, and especially as agent frameworks have become more prevalent, a single strategy for retrieval is to go from the sort of 70–80% quality to fit that gap. You need to have more tools in your box, essentially. Another problem we see is once you've got multiple types of content, you then need to find the definitive versions of documents, and often there is no easy concept of authority. But there's things that you can do about that to sort of have a proxy measure to help with that. Certainly in certain domains, I'm going to talk a little bit about safety sensitive domains. It's extremely important that you don't actively mislead people. And then the other big class where we're seeing that there are problems with a fairly straightforward approach is with multi-hop and relational queries. Now, some of the systems that I'm working on now are very much designed for that kind of relational workload, but because they're designed from the ground up for that, they work very well, but they don't work with other sort of more free text searches. So, you know, a multiple strategy approach is becoming more important. So with several projects now, we're working on trying to do query intent classification. That can be pretty simple. It can be passing into the LLM a few examples. This is what a parts query looks like. This is what a procedure query looks like. This is what a definition query looks like. Classify it, and then we'll take a slightly different approach to the query. The benefit of using that is you can ask the LLM, why did you choose that one? And it can give an explanation. That can get very sophisticated, including choosing different tokenization strategies or ways of indexing the content. And in an agent context, that would probably map to one or more specialist retrieval agents. So they might go to a glossary that knows about a concept index. You might have another one that knows about querying archives, or a particular query that you need to get back the actual content and not something that's gone through an LLM to provide a summary. And then with the advent of things like LangGraph, we're finding that you can sort of have a decision tree sort of approach where an agent might try and look at its context to understand whether it's got the information to provide an answer to all of the query. And if it doesn't, it might fall back to another strategy to do maybe a fuzzy match or a vector search. And it goes into a loop to try and investigate if it has the evidence it needs or the context it needs to provide the right answer. And if it doesn't, it may go back to the user and ask for a clarification or provide caveats in its response. And then just returning to the topic of authority and freshness, you can handle those through a simple scoring mechanism. If you have a way to understand that a document is current, you can give it a score as a class 1 document, and that can be used directly in, especially if you've got hybrid search, in boosting it. We've also seen cases where people are annotating the documents with to and from dates for applicability, and that can be very useful for understanding when a piece of content is valid. If the to is null or empty, then it means it's valid now. So that sort of a perhaps a fuzzy boost can be very useful to surfacing the right sorts of content and making sure that they're fresh and up to date. Again, this can combine with what I was just talking about, having multiple strategies. So authority can be determined by the strategy, because you might want to prioritize published PDFs, for example, rather than anything that's in draft. And then we did some very interesting work around auto filtering to sort of tackle the same sort of issue, where we would try and pluck out clauses like last year or deck or PowerPoint and translate that into a structured filter that we could then apply to the documents. We tried multiple approaches. The best one seemed to be to pass the schema or the relevant parts of the schema to the LLM, or allow the agent to interrogate and validate it and find the right piece, and then do a text to SQL, because LLMs will be trained on more SQL than they have Elasticsearch syntax, and then the search engine itself can do an SQL to its own domain specific language. That's what DSL means, which it does a very good job at. So that intermediate step seemed to be the best performing approach for this sort of auto filtering approach. And that just reduces the search space, means that you're getting as quickly as you can to the set of information that you want to answer the question from. These are important largely because of trust issues. What we do see is that in certain domains, you can lose people. You give a wrong answer and they're just like, well, this doesn't work. And so you do need to try to aim for fairly high quality bar, plus have caveats, plus have the feedback loop that we all always keep talking about. And with a decent feedback loop, you can address those issues as they come up. Okay, so that's some techniques for improving retrieval, making sure that you're not getting into the wrong documents. And then I just wanted to say something about knowledge graph, just because when we last spoke about that, or I've written a blog article about it, things have moved on a little bit, and I'm now seeing people really actively using knowledge graph in these sorts of implementations. Almost always it's where they have one lying around already, well, not lying around, but available already, that they can leverage. I've not seen many cases of people building a knowledge graph from their unstructured data. I've seen POCs and prototypes like that, but the successful cases I've seen where there are relationships between entities already well defined, either in the data model or through a ontology or knowledge graph that can be brought to bear. And then you can make a decision about whether to loop through several steps through a graph to get answer based on relationships, or whether to just do a straightforward query. Again, you might have a loop that sort of validates whether you need to use the graph to get more information to fully answer the question. Yes, so we would often use that selectively. If we can answer straightforwardly without needing to use a graph, we will. And again, having a graph to traverse plus embeddings plus a regular search as tools, it brings big gains. So Yeah, I just wanted to flag up really that we are now seeing out there, if you're considering it, the techniques are becoming more mature, and we're seeing some really quite impressive results from some of our clients now. And then answer generation. There's a little bit of overlap here with the previous section. These problems will be very familiar. LLMs can hallucinate. We all know how to kind of put into the prompt. If it's not in the context, don't give an answer. But you can still get a distortion of truth, and you can have certain domains. I've been working with a vehicle manufacturer. We've also worked with some legal bodies and some financial organizations where you just can't afford to, if it's safety, where you can't afford to not give the right answer. And even, putting in what safeguards you can with the prompt. But there are things you can do about that. And then again, similar to the previous example where you might have requests requiring multi-steps, you might also have multiple intent where, or it's ambiguous. So there's things that we can do that by having a fairly lightweight step that tries to break the query down and determine a strategy, essentially. And finally, again, for regulated domains or safety sensitive domains, attribution is important. Making sure that the person can get straight to the right part of the content and understand the bigger picture of where the answer or the citation is coming from is extremely important, and is more important than having an agent or a system answer for the source document. So what can we do about these? So for query decomposition, that can be done quite easily really with an LLM. Just a simple prompt to say, is this multiple steps? Please break it into multiple queries and return it in an array, and then handle it that way. That works quite nicely. And then if you're implementing multi-strategy approach, you can then decide what's the best source to approach those. Similarly, ambiguity detection, we have been working with a client recently where, as I say, they assemble the evidence and they don't move forward trying to provide an answer unless the evidence is clearly there. If it's not, they will go around and ask clarifying questions. I've also tried out using a sort of simple give me a percentage certainty response. Didn't work very well in practice, but I think there's some mileage in some additional research there. And then finally, there's a step to just put the different pieces of content together and provide a fused answer from the different small queries that are used to build it up. Then, yeah, I mentioned this already. So a bit more detail about how to deal with high stakes content or content where you can't afford to give an incorrect answer. One technique we've used is to simply provide from the retrieval step, you evaluate if you think you've got the content with the answer. If you don't, you go through another strategy. If you do, you ask the LLM to respond with the context snippet ID that answers the question, and then that original material is returned. So from the user's perspective, it looks a bit like it's not a question and answer system. Sometimes you can provide the LLM generated answer alongside, but you're in a situation where it's non-negotiable, and then perhaps the documents have been signed off and are regulated in some way, we still wouldn't recommend having an LLM potentially translate that a little bit. We haven't been able to get a perfect way of doing that yet. Another case is with document search first, where if we've got a domain where perhaps you've got a classification structure for your documents, or they're labeled according to some kind of typology, we'll let the user do some work and tell us what sorts of documents, give them a list of possible candidates, let them choose which documents to answer for, instead of having the system trying to work that out. Domain knowledge is useful, so we will use it in these important domains where we have that opportunity. Then the last section I want to talk about is performance. We're now seeing some customers who've got, there's one document management system where they got hundreds of millions of documents, and trying to do a chat system across that causes some headache, shall we say. Simply because the retrieval aspect is just so much more difficult. But performance and capacity management are also an issue. So I thought this would be interesting. This is made up of, I think, 4 different clients. One was concerned with latency and throughput of very high query volumes, just wasn't responding quickly enough. Then we've got the trade-off between quality and performance, because there's things you can do to improve quality, improve performance, but that is often by degrading quality. And then finally, about an idea that we put into place to reduce the complexity for a specific customer. So this case, we were being asked to meet 95th percentile, so 95% of queries for a RAG system, it's a question answering system, at less than 200 milliseconds at a rate of 65 queries per second, using a publicly available, very well-known publicly available AI provider. The actual latency was around about 600 milliseconds, which was unacceptable. This is simply for the embeddings step of taking a question and turning it into embeddings. We analysed it and discovered that it's essentially the network hop, which is causing the problem. There's nothing we can do about that. They don't offer any SLAs. Doing some research, we didn't find any other providers who are going to materially improve matters. So the approach we took was essentially bring it in-house. Take an open source embedding model, put it into SageMaker so it's much closer to the source system. We benchmarked it again, and the 95th percentile, so 95% of queries were now being embedded within 144 milliseconds at that rate, with a mean of 144 milliseconds, with a mean of 95 milliseconds. So that's a more than 6-fold improvement. And it's worth saying that the open source models, they kind of flip-flop, but they're often around the top of the leaderboards for embeddings. So we weren't too concerned about quality there. You just have the slight overhead and cost of hosting it yourself, but that needs to be balanced against the cost of a metered service. So there are things you can do. And the second case was actually I've got 2 sort of merged very similar customers here. Both of them wanted to use Matryoshka representations, which is essentially, if you've got 1024 length vector embedding, you order the embeddings by the amount of semantic value they bring. And that means you can cut them off and just use the first 128 or whatever. There's some stats out there say that compared to a 1024 dimension vector, a 256 Matryoshka one has a 4 times storage reduction, but only a 2 to 3% loss in quality. And that was kind of our experience too. So this is very interesting if you're struggling with large storage across large embeddings, large network overhead, all that sort of stuff. So we evaluated this with a couple of test harnesses. As I said, it's 2 different customers. One, they already had a golden query set that we could evaluate. So for that, we could use traditional information material metrics such as recall. And what you would see was that sometimes the 9th or 10th result would slip out of the top 10, but not very often. And in the second case, we had to develop our own test set against Wikipedia and we used some of the open source tooling out there. Again, quality was satisfactory, not as good as with the golden query set. But point being, we were able to massively reduce their storage footprint by using MR and quantization to reduce the size of the storage, whilst pretty much maintaining quality. And then this last case was one of those ones I've just mentioned, where we were reducing storage overhead and ensuring that performance and RAM and so on were optimally used whilst maintaining quality. In this case, they had a separate vector, sort of chunked index, and then the full document, and they were using both. We were able to quite cleverly combine them so that you've got the chunks as nested objects within the documents, and then a single document for the text, for the raw text. And that meant that they didn't need to replicate tens of thousands of metadata fields they had on some of their content over and over on each chunk, which again enormously simplified their storage and the complexity of maintaining two different index with different jobs. They were able to repurpose a cluster and actually decommission it with all the savings associated with that. We haven't heard, I don't think they've fully rolled that out yet, but they were estimating it would save them about 75% in terms of storage costs, which was an infrastructure cost, which is enormous for them. So with some clever index optimizations, you can get some really good gains. I mean, essentially, this customer was stuck, unable to move forward, and yeah. So there's techniques you can do to simplify your indexes to help with storage and performance. So I'm going to wrap up now. I've just got a few key takeaways. I covered a lot of things there. So I'm hoping we might be able to share the deck because it's quite wordy. But adapt the chunking strategy to your content. Consider intent-based agent routing, especially if you've got very diverse queries or diverse content sets. Think about authority scoring as part of that, because not all documents are created equal. If you have a problem with complex queries, people trying to do things that you never really anticipated when you first rolled out your system, you can take a step to decompose queries. Obviously, all of these retrieval side steps that I've been mentioning do have a little bit of an overhead in terms of token usage. I know people are very sensitive about that, and also latency. So these things have to be balanced. But again, you can balance that against cost and performance by some sort of smart indexing strategies and also reducing your vector footprint. Okay, so I think we might be at the end. So thank you, anybody who's still on, for attending. And we can also always handle any other questions kind of offline.
Yeah, and like I said, if anybody would like a copy of the presentation, if you could let me or Martin know, and we'll send that through. And yeah, and as Matt said, thanks very much for joining. I hope you found that interesting. And yeah, we'll be in touch soon. Okay, thanks again. Bye-bye.